continuing our study, haha, see what I did there? We have continuous functions, and some functions are continuous over their domains, like rational functions. They're continuous everywhere they don't have a vertical asymptote. Okay, trig functions, square root functions, fourth root functions, anything like that. So let's just look at an example with those. You can read that. I really like this example part B. I really like it because you got to know about logs and you got to know about trig functions. But we'll start with part A. In this example, x squared is continuous for all real numbers, and sine is also continuous. I'm going to go fancy again for all real numbers. So that means that h of x is continuous for all real numbers. Oh, that was simple. This one's a little bit more involved. Let's think about cosine of x plus 1. All right. The domain of cosine of x plus 1, or just cosine of x, that's all real numbers. Okay. Now, ln of x, though, the domain, x has to be greater than 0. So we need to worry about where our inside function is greater than 0. Okay, and if you think about it, cosine of x plus 1. Where is that equal to 0? Well, we have cosine of x equals -1, and we know that cosine equals -1 at pi, and everywhere, if we go around the unit circle, any of those values. So if cosine of x equals -1 and cosine x plus 1 equals 0, then that's not going to fit. That's not going to make h of x continuous there. The other thing is cosine of x plus 1 always greater than 0? Well, the range of this, since it's just the cosine function moved up 1, instead of being -1 to 1, it's 0 to 2. So that range right there is 0 to 2. So it's going to be greater than 0 everywhere but where it equals 0. So this, we're finding our domain. The domain is, we won't do it that way. We'll say all x not equal to pi or any coterminal angle to pi. So we have this nice colorful picture. Sorry you don't have color. This is the intermediate value theorem. Sounds really complicated. You can go ahead and read it, but it's simple. Basically, what it's saying is if you go from one y value to another with a continuous function, it has to cross through every single y value in between those, which sounds like common sense, but it could be kind of complicated. And so for a theorem to apply, the if part must be met before we can apply the then part. So keep in mind, if a function is continuous on a closed interval, that's the if part. We have to say that is true before we try to apply the intermediate value theorem. So if we measured the temperature outside to be 47 degrees Fahrenheit, then measure it again and it's 62 degrees Fahrenheit, we have to explain why there must be some time where it's exactly 51.351 degrees Fahrenheit. So remember that if-then thing. So is temperature going up and down continuously? Yeah, of course it has to. All right, let's try to word that. Let's see, the temperature has to progress, that sounds fancy, has to progress continuously. we'll say through all of the values from 47 degrees Fahrenheit to 62 degrees Fahrenheit. Over the time, we'll say that's specified time interval, 8:15 to 12:15. So at some point, it must be 51.351 degrees Fahrenheit by the IVT. So at this point, there's no exact way to determine what time it hits that unless we had a lot more data or a function to model this data. Okay, we'll look at it with a nice piecewise theorem here. A piecewise function. We got to determine if the IVT applies at each of these intervals. I'm going to try to save myself time and figure out where it is discontinuous first. So if we evaluate limit as x approaches -2 from the left, we get 5. Limit as x approaches -2 from the right, hey, we get 5. And f of -2 exists, and it's 5, so it's continuous there. We're good. If we check 1, limit as x approaches 1 from the left, it's going to be 2. Limit as x approaches 1 from the right, it's going to be 3. So it's not continuous at 1. Okay, and then we'll check 4. Limit as x approaches 4 from the left would be 6. Limit as x approaches 4 from the right, 6. So we're good at that value. Okay, this one, x can't be 5 because we have a vertical asymptote there. So our function is discontinuous at x equals 1 and x equals 5. Okay, that'll be important to remember. So, does the IVT apply from this closed interval, -4 to -2? Explain. So, yes, because f of x is continuous for all the values on that interval. Okay, how about -3 to 0? Same thing, okay? Yes, f of x is continuous for all the x values on -3 to 0. Okay, C, now this one we got to be careful with, all right? The function is not continuous at 1, but what's the left-hand limit since we're looking from the left side? Do you remember? That would be 2, I believe, right? And then, yeah, let me write that down. Limit as x approaches 1 from the left of f of x is 2, and f of 1 is 3. They're not the same. So no, the IVT does not apply. F of x is not continuous, since the limit as x approaches 1 from the left of f of x is not equal to f of 1. This one I'd like you to do in your whisk. And then the last one, since we caught that vertical asymptote there at 5, no, the IVT does not apply because f of x is not continuous at x equals 5.